You can work in your groups on this. It's the product of our two ages is 156. What's the product? Flynn?
Multiply what you multiply. The answer.
The answer you get when you multiply. And the sum of our ages is 25. All right. So there are two people. What we want to find out is how old they are. But it has to fit both parts of the question. So you're going to look for two numbers that when you multiply them together, you get 156. When you add them together, you get what? 25, right. All right, you can work in your groups for a couple of minutes. When you have it, one person from the group, I want to see the work done. Put it on one paper like you usually do. I'll come around, coupon for the group. One for this one for the next one. Got it already? Multiplication done? Let's see. You're right. All right, turn it over, please. Remember the different ways you can do it, trial and error. If you multiply two numbers and it comes up too high, go down at least one. Can both people be the same age? Why, Sarah?
If you add the two ages together, there's not an even number. You can't have two even numbers that add up to 25.
Okay, there are no two numbers the same that something plus something would be 25. You've got to get the ages. Don't forget the ages have to equal 25 when you add them together. What are your two ages? 12 and 13 is right. Partners have to help here. Make sure they help on the next one. Turn it over. Give me another couple of minutes to work on this one. Remember, what you're doing is when you multiply two numbers together, they have to equal 156 for your answer. So you're going to have a number here and a number here. Then, when you add the two numbers together, they have to equal 25, those same two numbers. So what would be the easiest way to look for it first? You think the multiplication or the addition? Anyone? Probably addition. If you look and see what two numbers you can add together to get 25, and then try the multiplication of those two numbers. So what combinations can you add to get 25? Start with that. Did your group already get it? No. All right. Think about what you think about. Oh, okay. All right, that's 18. Okay. But now that doesn't multiply to 156, right? Give me another minute. Well, now try and see what happens if you multiply those. What other groups here? Or restarting. Let's say a starting point. Are you multiplying or adding? All right, one more minute on this one. Multiply those? Yep. How about the last two groups here? Now when you add 15 and 12, do you get 25? So we know that can't be right, so don't even do the multiplication part. Do the addition part first. What two numbers can you add together to get 25? Okay, but if you multiply 15 times 10, what's it going to come out to? Okay, you're close, but you're not exact. So Instead of 10 and 15, you might want something in between those numbers. All right, are you going the wrong direction? What did you have before? How about this group? Okay, look up here. What did you start with for adding? Jennifer had said 10 and 15 would equal 25. That would take care of this part, but what happens when you multiply 15 times 10? What do you get, Flynn?
You get 150.
All right, 150. We're close, but we're still not there. All right. Tareen, what did you do?
I did 13 plus 12.
All right, is 13 plus 12 or 12 plus 13 25?
Yeah.
All right, what happens when you multiply 13 times 12? Does that come out to that?
Yes.
3 times 2 is 6. Got your right answers there. 13 and 12 the people are. All right, this one's going to be a little harder. This one's 2 coupons. You will have until 5 of. At 5 of, we're going over it. 5 of. 5 minutes you have. Remember we did a problem talking about saving money and saving a certain amount of money on one day, certain amount the next day. This says on May 1st, Larry began saving money. He decided to put away a dime each day. On May 8th, Elizabeth also began saving money, but she decided to put away 15 cents each day. Bless you. On what date will Larry and Elizabeth have saved the same amount of money? And how much will it be? Larry is saving 10 cents a day. Elizabeth is saving 15 cents a day. First look to see what day Larry is starting on and what day Elizabeth is starting on. You might want to make a chart for this one. You might want to make a chart.
Okay, so let's see.
Got it already?
Well, no, we have to ask a
Oh,
question.
okay.
Can the days be different? Or do you want the same day? Same day.
Larry has to start on May 1st, and he has to put a dime away each day.
So I'm saying, can the dates be different? I mean, can like one be like the 10th and the other one be like the 20th or whatever?
Well, they're asking you on what day will they have saved the same amount of money. On what day?
Oh, so
One
the
day.
Same day? Okay.
Right, one day.
So it has to be the same day.
It has to be the same day, right.
Oh, okay. Well, yeah.
And the same amount of money, right. So if you look over here and you start with Larry on May 1st, and he's getting 10 cents, May 2nd, how much will he have saved?
20.
May 3rd, and keep going that way. Maybe you should do the same thing with Elizabeth
Okay, I'll do Larry.
and see what day that the two totals will come out exactly the same. And you have to see what date it is.
Why don't we do all these? If we did all the products. I mean, all the
Don't forget, you're only adding a dime each day. You're not doubling it like we did before. All right, you're adding an extra dime each day. That's right, you keep going on.
Yeah, but those are 2 different days.
Right, but he's getting the idea. This is Larry here. This is May 1st. May 2nd, May 3rd, like he's doing it. And then who is this? Elizabeth. This is on May 8th. But you may not want to do it across. It might be better going up and down, and we'll see. And what's the amount of money? Okay, well, wait and see.
No, the ninth. How much? No, she doesn't. Now Elizabeth.
Did you go in order for the dates? Because you don't have the right answer. You better check again. You better check between your 13 and 14. I think you goofed up there, which is going to change your answer. Anybody coming close to the same number yet? Yep, you're on the right track. Mm-hmm. How can what?
How can we do it going down?
Well, why couldn't you put your dates going down, like May 1st, 2nd, 3rd, 4th, and keep going down this way? Maybe if you put Larry's numbers here, 10, 20, 30, by each date, and make another column over here, leave those same dates, and on the 8th, you're going to start with Elizabeth at 15, 30, counting by 15s. When you get down to a certain point, they should have the same numbers. And if you have the dates going down here, you should be able to see which date it is. What do you have to do to find out how much Elizabeth has each day? What are you counting by?
15.
Counting by 15. How about for Larry?
10.
You're counting by tens.
What did you get for the 10th, David? For Elizabeth.
Who has it? Somebody have it? How much did you jump between here and here? Is that a difference of 15 between 120 and 145?
No.
So just work from here on because you're close. Another 30 seconds. Anybody close? What would this problem have been if easier if I gave you? What would have made it easier for you to do instead of all this adding? What if I had given you a calculator? Think it would have taken less time?
Yes.
Especially with our Explorer calculators, where you can keep hitting one button and get multiples.
Ooh,
Getting close.
getting very close. And I hate this suspension.